Okay, good evening, all of you. In the second session of simple harmonic motion, we'll be discussing about pendulum. So, in today's session, we'll be discussing about pendulum. Okay. Now, what are the two formulas related to pendulum? So, broadly speaking, which are the two formulas which we usually think about when we are speaking of pendulum? So, one is the simple pendulum. So, simple pendulum, you know that time period is 2 pi root L by G. So, in a simple pendulum, the thing which matters is the length of the pendulum, that means the length of the string, and acceleration due to gravity G, and in a physical pendulum, the time period is 2 pi root moment of inertia by mgl. Now, what exactly is this formula all about? Okay. So, first of all, what is a physical pendulum? So, a physical pendulum is basically a rigid body which is suspended about a point on it. So, suppose there is a rigid body and it is suspended about the point O. Okay, on that body there is a point O and it is suspended about the point O. So, the axis of rotation will pass through the point O, and I can give it a name like OA. So, OA will be the axis of rotation, and C is the center of mass of this rigid body, and the weight of the rigid body is mg, and the distance of C from the point O, that distance is L. So, once again, suppose there is a rigid body and it is suspended about a point O on it, and the C is the center of mass of the rigid body, the weight of the rigid body is mg, and the distance of C from O is L, and the axis of rotation uh, is OA. So in this formula, L stands for the distance of C from the axis, that is L. Mg is the weight of the body, and I is the moment of inertia. I is the moment of inertia of the whole body about the axis OA, right? So L is the length from O to C, Mg is the weight of the body, and I is the moment of inertia of the body about OA. So this is physical pendulum. So in this chapter, we will be in this session we will be looking at questions which are based on either simple pendulum or based on physical pendulum. So these are the two topics. Okay, now let's have a look at one question. Okay, now let's have a look at one question. There is a meter rule. Okay, there is a meter stick. It is suspended about a point. This distance is 10 centimeter. Like from here to here, this is 10 centimeter, and this is 40 centimeter. So it is suspended about this point. So what is the time period of oscillation about this point? So this is a meter stick. It is suspended about a point which is 10 centimeter from the top. And what is the time period of small oscillations about this point? That is the question. So this is 10 centimeter, this is 40 centimeter. So you have to find the time period of oscillations. So first we have to find the moment of inertia. So moment of inertia, you have to use parallel axis theorem. So ml square plus md square. And in this formula, L is 1 because it's a meter stick, and D is 40 centimeter. Okay, because from the center it is 40. So m into 0.4 square. So moment of inertia ml square by 12 plus md square. So m into 1 square by 12 plus m into 0.4 square. This is the moment of inertia. So the time period will be 2 pi root over, and then you just take this moment of inertia thing, m into 1 square by 12 plus m into 0.4 square, and you divide it by mg into the distance so distance is 0.4, right? And this will give you the time period. So you'll find that m is getting cancelled out, and if you calculate it will come to 1.55 seconds. So this will be the answer. So there is a uniform meter rule. It is suspended about a point which is 10 centimeter from the top. So from the center it's 40 centimeter. So moment of inertia about this axis will be ml square by 12 plus md square. So it's a meter stick. So m into 1 square by 12 plus m into, from the center this point is 0.4. So m into 0.4 square. So time period is 2 pi root over moment of inertia by mg into 0.4. So that is coming 1.55 seconds. So this is an example of how you can do the sums of physical pendulum. To be very honest, simple pendulum I don't think needs much introduction. So I'll do one thing, I'll straight away give you the homework. So question number 1, if the time period is 2 seconds, when it's a seconds pendulum, then find the length if g equal to pi square meter per second square. That is question number 1. Question number 2, if the maximum tension of a pendulum is double the minimum tension, find the angular amplitude. So that is question number 2. Question number 3. Okay, question number 3. A uniform rod of length L undergoes small oscillations. Find the length of a simple pendulum having the same time period as the rod. This is question number 3. Then question number 4. Question number 4. The pendulum of a clock has time period 2.04 seconds. So how fast or slow is it in 24 hours? This is question number 4. And question number 5. Actually, this question is not from pendulum, but this is a general simple harmonic motion. That there is a small block, it is oscillating on a concave surface of radius r. So, what is the time period of small oscillations? Okay, so this is not a pendulum sum, but it's a general simple harmonic motion sum, right? So these are the 5 homework sums. If time period of a pendulum is 2 seconds, that means it's a seconds pendulum. What is the length? If g is pi square meter per second square. If maximum tension of a pendulum is double the minimum tension, find the angular amplitude. 3. A uniform rod of length L undergoes small oscillations, find the length of a simple pendulum having the same time period as the rod. 4. Pendulum of a clock has time period 2.04 seconds. How fast or slow is it in 24 hours? And 5th, there is a small block oscillating on a concave surface of radius r. What is the time period of small oscillations? So these are the 5 homework questions based on pendulum. You can submit it by 9 p.m. tomorrow, that is Friday. So I'll end the meeting for now. Thank you and bye all of you.